Humans like little Jimmy. Plants like the fleece flower. Fungus like the bleeding tooth fungus. Crustaceans like giant isopods. Why, yes, even man's best friend. What do these things have in common? That's right, they're all examples of eukaryotic organisms.
Alright, the eukaryotic organisms, but what does that got to do with endosymbiotic theory?
Well, other Jimmy, if you just shut your pie hole and let me finish, I'll tell ya. You see, eukaryotic organisms have complex membrane-bound organelles such as the nucleus, the endoplasmic reticulum, the Golgi apparatus, mitochondria, and chloroplasts. Endosymbiosis is all about the mitochondria and the chloroplasts of the eukaryotic cell. Here we see a mitochondria. Hey, those are prokaryotic E. coli bacteria, but they sure do look like mitochondria, don't they? And here we see prokaryotic plant cells filled with chloroplasts. Wait a second, those are prokaryotic cyanobacteria. How did you get in here? Hey Jimmy, pay attention. Endosymbiotic theory states that many of the key organelles of eukaryotes evolved from a symbiotic relationship with early prokaryotes billions of years ago. Dang it, Jimmy, you're on the goofballs, aren't ya? Anyways, one of the ways cells can get the nutrients necessary to survive is through a process called phagocytosis, in which they envelop themselves around another cell to consume it. And this is where we get into the meat and potatoes of endosymbiosis. We start with two independent bacteria. One bacterium engulfs the other. One bacterium now lives inside the other. Both bacteria benefit from the arrangement. The internal bacteria are passed on from one generation to generation. But what evidence is there to support this theory? Well, for one, mitochondria and chloroplasts have their own DNA and ribosomes separate from the cell they reside in. They have circular DNA similar to prokaryotes. They have their own membrane within the host cell. Mitochondria even share some of the same genetic information as bacteria. But you don't have to go back billions of years to see these kind of relationships. This is Paramecium bursaria. And through the magic of Technicolor, you can see that the paramecium is filled to the brim with chloroplasts. But it didn't grow those chloroplasts. Oh no! It consumed green algae. Now, in addition to consuming things through phagocytosis, this paramecium can also photosynthesize sugar. But it's not an exploitive relationship. You see, the paramecium now can move those little guys around into the sun so they can get optimum exposure. And when there's no sunlight, he'll keep his little green algae buddies alive with nutrients he collects himself. So how do you fit into endosymbiotic theory? Well, if eukaryotic life had not evolved, it's plausible to think that multicellular life as we know it might not even exist. Like Marty McFly, we might have never existed.